You're watching the Weiss channel. Dot, 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 dot. All right, here's what we're doing today. Today is called normal distribution with population size. Doesn't that sound complicated? All right, watch how easy this is going to be. Now, first of all, I need to have you see this and remember this. Do you remember this? All right. Here, I showed you, for example, the mean is 100 and the standard deviation is 15, which means one standard deviation to the right is 115, and then two standard deviations 130. Three standard deviations is 145, right? And then one standard deviation to the left would be 85, and then two standard deviations would be 70, and three would be 55. Now, if you're within one standard deviation, remember 68%, right? That's 68% of the data from 85 to 115. So if the question asked, what percent of the data is within one standard deviation, or what's for the percent of the data that is from 85 to 115, your answer would be 68. And then if it said, what percent of the data is between 70 and 130, your answer would be 95%. And then if the question said, what percent of the data is between 55 and 145, your answer would be 99.7%. Okay, so we're doing kind of the same thing, but this time, do you see how here the mean is 800, all right? The standard deviation is 35. Do you see here that they're asking for two numbers that are not even one standard deviation or two? It's some number in between. So how do we find one number or two numbers in between the standard deviations? That's not a given percent. Okay, we have to find that percent, but this is going to be really easy. And here is what you're going to do. In all of these problems, you're going to click on Statistics Calculator down here. Okay, click on that, and then don't get flustered by all this mess. All right. Up in the main menu, you click the drop down, and because it's a distribution, you click on distribution. Okay. Now, under the sub menu, you're going to go to what's called normal CDF. Normal CDF. What the heck is normal CDF? Normal CDF stands for normal cumulative distribution function. You don't have to know that. I just want, in case you're wondering what the heck is normal CDF, it's normal cumulative distribution function. Okay, don't worry about that. Just remember normal CDF. Okay, now it says lower, upper, mean, and standard deviation. Remember, mu stands for mean, and this Greek letter S, sigma, stands for standard deviation. Okay, so we're going to look back here. And what is the mean? Okay, the mean is 800. Okay, so the mean is 800. So we go to our calculator here and we put 800 for, 800 for mean. Okay, now what's the standard deviation? The standard deviation is 35, right? It says right here, 35 hours. Okay, put in 35. Okay. What is the lower number that they're asking about? Okay, they're asking 780. It says, how many would be expected to last between 780 and 820? So the lower number is 780. The upper number is 820. So go ahead and put in 780, 780, and the upper number will be 820. And now you hit calculate. And it gives you this 0.4322909. So now what you do is you go to just a regular calculator and you're going to put in 0.4322909 times what is the amount, all right? It says out of 85, okay? 85 out of 85 freshly installed light bulbs, okay? So we're going to multiply by 85 times 85 equals, and your answer is 36.7. And it says to the nearest whole number, so your answer is going to be 38. Okay, so I'm going to just go down here and show you that your answer 37. Sorry, 37, right? What was I thinking? 36.7 rounds to 37. Okay. Okay. There we go. Now, here's another kind of problem you're going to see. Okay. This one, all right. At a local restaurant, the amount of time that customers have to wait for their food is normally distributed with a mean of 30, standard deviation of 5 minutes. If you visit that restaurant 24 times this year, what is the expected number of times that you would expect to wait longer than 34 minutes? Notice there aren't two numbers here. There's just the one, which looks like this. See, it's just one number, 34 and higher. So here's what we're going to do. We're going to still use this same calculator, but this time the lower number is 34. Okay, so we're going to put 34 in for the lower number. Well, what's the upper number? We don't have an upper number. So here's what you're always going to do for an upper number when you don't really have one. We're just going to put in this 99999999999. Okay, just put in a bunch of nines, okay? Because you can't, there's no infinity, right? Because technically it goes up to infinity. We just put 9999999, okay? The mean here was 30. So we're going to put the 30 for the mean. And the standard deviation was 5, right? Yes, 5. Okay. So once again, we're going to calculate. And here your number is 0.2118553. So we're going to clear. We're going to put 0.2118553 times how many? What was the number? If you visit that restaurant 24 times, so it's times 24. 24, it equals, and you get 5.084, which is going to round just to 5. Okay. So you'll see, just like we did, 5.08452272 rounds to 5. Okay. Now, here's one more type of problem you'll see. When Aaliyah goes bowling, her scores are normally distributed with a mean of 105 and a standard deviation of 10. Out of the 50 games that she bowled last year, how many of them would she expected to score less than 113? The nearest whole number. So this one, less than. So see how less than, again, you're just getting one number, not two, but this time you're asked less than. Okay, less than. We're going to do almost the same thing. All right, so we're going to go back to the calculator. This time, the upper number is not 99999. The upper number is 113. That's the upper number. So we're going to put in 113. Okay. And the lower number, remember how we used 9999999? Well, in the negative direction, it's going to be negative 999999999. Okay? So put in a bunch of nines, but make sure you put in the negative. If you don't put in the negative, you're going to get messed up. The standard deviation is 105. Okay? 105. And I'm sorry, the mean. Sorry, the mean is 105. The standard deviation is 10. Standard deviation is 10. We click calculate and we get 0, wait, clear. We get 0.78814447 times how many are we dealing with? Out of the 50 games. So it's times 50 times 50 equals 39.4 will round to 39 will be your answer. Okay, let's double check. 39. Okay, that's how you do these problems. Now, I want to one more time, I want to make sure you understand where you're going on the calculator. Okay, one more time, watch this. You go to statistics calculator. Under main menu, you go to distribution. On the sub menu, you go to normal CDF, okay? And this is where you'll put lower and upper, the mean and the standard deviation, okay? Okay. You've been watching the Weiss channel.